Welcome to PipeMath, and this is Aman Khan. Uh, I'm going to show you our first module on pipeline wall thickness calculation and analysis. PipeMath is this module particularly designed to meet the CSA Z662 requirement, which is Canadian code for pipelines. So on very first tab, we will enter the project information. Mostly we are doing it to show you that how our final report will look like, and these are all the placeholders on the final PDF report, which software will generate at the end of the calculation. So we are designing this pipeline for natural gas, and we can assume job number for this example. So this information, we are assuming this to show on the PDF report. Revision number we can say 0, and it will be originated by Aman, myself, and then checked by Derek, and then designer is Peter. We also have an option to import the signatures. So as I said, like, we are designing this pipe for sweet gas service, and there are no threaded connections. There are no DGAs, which are designated geographical areas. We assume 9000 kPa system at 60 degrees Celsius with installation of -10, and we assume a 12.7 millimeter pipe wall thickness. 36-inch pipe, class 1, and service is gas, general, and pipe type will be electric welded. So no corrosion allowance. So PipeMath is calculating the wall thickness 14.12 millimeter, which is more than that, which we assumed 12.7. So we will change the grade, which will bring us to 12.42 millimeters, which is within the limit, but we still have an installation temperature higher than our assumption, which is -10. So we'll increase the grade one more time to 483. So temperature is well below -10. We'll move to the strength test calculations. So at this stage, we want to assume a possible differential head pressure because of the change in elevation along the right of way, and we assume 30 meters. We'll be testing this pipeline with liquid, most probably water. So we have, like, our pressure for 100% SMYS and 110% SMYS is definitely higher than the required pressure. So flange analysis, we are again assuming CSA flanges, 600 class, so it is adequate. Our pressure is 11,250. Now we move to the material selection, and we select Cat 2 pipe for this project with -10 installation temperature. So our software has calculated Cat 2 requirement for this pipe material, and we already selected Cat 2, so it is acceptable. Now we can move to the next tab, which is bend analysis. And bend analysis, we will assume triple random length with double joint, and bend angle is 90 degree, mill tolerance is 5, field bending radius is 1, pipe diameter 1 degree per pipe diameter and 5 degree for shop bend. So to produce a 90-degree bend, we need 87 meter pipe approximately. So we can increase the degree per diameter to maximum limit of 1.5 degree per pipe diameter, which can reduce the requirement of line pipe to produce 190-degree bend, which is 60 meters approximately now. And it is also calculating the wall thinning due to bending and due to mill tolerance as well. So we can notice that our percentage of outer fiber is 10%. Which is right up to the limit. So if we'll select 10D, which is right at 5%, which is very reasonable. So this is for the roping, and roping is always calculated based on the combined stress. So we have a grade of 483 MPa. Our combined stress margin is approximately 82 MPa. So if with 10% of SMYS, our bending radius is 1900 meters, and with allowable combined stress, we can reduce it to 1147 meters. So this is a buoyancy control analysis. You can change the density of steel, and insulation is not applicable in this case, but we can select soil type, and if height of water is above the pipe, you can enter in this field here. So this is the road crossing calculation. We assume the live load of 9,000 kg for this calculation. So everything is fine, no issues. And this is the last tab for upheaval buckling calculations, and you can do these calculations for clay and sand. So now if we are happy with our analysis, we can PDF it to see the results. And there are so many options that you can play with the parameters, certain parameters, and then you can come up to the desired design calculations. So this is the final report, which you can see in PDF form. So this report is presenting results of all the calculations. It's a kind of detailed summary of all the data assumed to perform these calculations, and it is giving us a good idea that how we can select line pipe wall thickness for the project, which is adequate for all the different conditions like buoyancy control, road crossings, and hydro test, and upheaval buckling as well. So all those cases are covered, and that is end of this presentation. Thank you very much for joining.